Hi, this is Frances Ostensen, and in this video, I will be going over a question from the chapter on acids and bases. The question is 17.10, and it focuses on finding the pH of a solution after the solution has been diluted. The question reads, what is the pH of a solution of hydrobromic acid that is prepared by diluting 20.0 milliliters of concentrated hydrobromic acid at a concentration of 11.6 molar to a final volume of exactly 500 milliliters? So molar in this case, symbolized with a capital M, stands for moles per liter. To solve this question, we follow three steps. First, we find the molarity of the solution at 500 milliliters, the final volume, using the relationship M1 times V1 equals M2 times V2. Then we'll figure out the concentration of hydrogen plus ions in that solution by setting up an equation for the ionization of hydrobromic acid in an aqueous solution. And finally, we will find the pH using the definition of pH, which is the negative log of the concentration of hydrogen plus ions. So for step one, we are given the initial volume and the final volume, as well as the initial concentration. And we need to solve this problem, we need to have the final concentration. To figure this out, we use the equation M1 times V1 equals M2 times V2. M stands for molarity and V stands for volume. We want to isolate M2 because we want to figure out the final concentration. So to do that, we make the relationship M2 equals M1 times V1 divided by V2. So since molarity is measured in moles per liter, we want to convert the milliliters that is given in the problem to liters so that our units will cancel. 20.0 milliliters equals 0.0200 liters, and 500 milliliters equals 0.500 liters. Then we put those numbers into the equation. So 11.6 moles per liter times, which is M1, times 0.200 liters, which is V1, divided by 0.500 liters, which is V2, will give us what we need. So liters will cancel on the top, and we end up with 0.464 moles per liter, or 0.464 molar. In step two, we need to find the concentration of hydrogen ions in this solution. So since hydrobromic acid is a strong acid, one of the big six, we know that it completely ionizes when in aqueous solution. We show this through the expression using a monodirectional arrow, which shows that HBr will separate into its individual ions H plus and Br minus when in solution. Because it separates into its individual ions and it is a monodirectional arrow, we know that the mole ratio is 1:1 from HBr to H plus. So therefore, the concentration of HBr equals the concentration of H plus. And since we figured out the concentration of HBr in the previous slide, we know that the concentration of H plus ions in solution is 0.464 molar. Step three is using that concentration of hydrogen ions to find the final pH. pH equals the negative log of the concentration of H plus ions. So we plug that into our calculator. Negative log of 0.464 molar gives us a final answer of 0.333 pH. In summary, we try to figure out whether or not our answer makes sense. So we started with a very high concentration of hydrobromic acid, and we diluted it by adding water to the solution, and we ended up with a much less concentrated solution of 0.464. This makes sense because, again, we're adding water, so it will become more diluted and a lower concentration. The second part where we found the concentration of H plus ions makes sense because HBr is one of the strong acids, so it will fully dissociate when in solution, and therefore the mole ratio between HBr and H plus is the same, or 1:1. Then finally, we found the pH of the final solution, giving us a final answer of 0.333 pH. This is a very, very acidic pH because it's very low on the pH scale. But that makes sense because we have a very high concentration. Even though it is considerably less than our original concentration, it's still a very high concentration of 0.464 molar. And again, hydrobromic acid is a very strong acid, so it's very low on the pH scale to begin with. All right, so our final answer makes sense, and that is how you solve this problem. All right, thank you so much for watching, and